Yogaha Karmasu Kaushalam.
Hello everyone, I, Dr. Tanvi Kothari, faculty currently associated with Sri Jairambai Patel Institute of Business Management and Computer Application, thanks UGC Human Resource Development Center of Gujarat University for providing me this an opportunity to connect with you all and deliver my session on basic statistical test for hypothesis testing using SPSS. I thank Professor Jagdish Joshi, Professor and Director of UGC HRDC of Gujarat University. HRDC Gujarat University is ranked 15th in India and number 1 in Gujarat. It is the first of its kind online refresher course in India in the year 2018-19, which offers online refresher program in English language teaching, which is called ARPIT, with record-breaking 9,000 participants in the year 2019-20. It is very innovative and established training institute. So, with this thanks note, I would like to start my session. So today we are going to talk about the basic statistical test that we use for test our hypothesis using the SPSS. So let's first understand what is hypothesis. Right? A hypothesis is an assumption or a statement that may or may not be true. The hypothesis is tested on the basis of information obtained from a sample. And hypothesis tests are widely used in business and industry for making the decision. So what it says that hypothesis is an assumptions of a researchers, that what researchers are assumed, and that may be true or may not be true. It is totally dependent on researchers, that what kind of assumptions they are making. Researcher 1 may make some different assumptions, researcher 2 may make some different assumptions. And so it is researchers assumptions, and we can test our hypothesis based on the basic informations that we collect from our samples. So this is the widely used method for making the decision in industries and the business. So there is a typical 6-stage process for a hypothesis testing. First stage is about setting up the hypothesis. Then it comes the setting up suitable significance level. Then there is a determination of test statistic. There is a determination of critical region and computing the value of test statistics. And at last, making the decisions. So, what is the first stage? Setting up the hypothesis. So, to set the hypothesis, it is required to understand that there are two types of hypothesis: null hypothesis and alternate hypothesis. What is null hypothesis? Symbolically, it is represented by H0, or you can say H0. It is tested for possible rejection under assumptions that is true. So say as a researcher, if I assume that the sales of my company is increased due to the advertisement or due to the promotion campaign that company is having, so that is my assumptions. So what is the null hypothesis in such case? That ड्यू टू द एडवर्टाइजमेंट देर इज नो चेंज इन द सेल्स जैसा है वैसे का वैसा ही रहेगा, देर इज नो चेंज इन द सेल्स. सो दैट इज अ नल हाइपोथेसिस. सो वी ऑलवेज वांट that null hypothesis must be rejected. So theoretically a null hypothesis is a set as no difference or status quo and it considered true until and unless it is proved wrong by the collected sample data. So until and unless we prove that our assumption is true, it is always considered that null hypothesis is true, that there is no effect of promotion campaign on the sales. So that should be considered as a true. Unless and until we collect the data, then we apply some statistical test and prove that it is not true. A null hypothesis may be rejected, but it can never be accepted based on a single test. So it may be rejected by the data that we have collected from our samples, but it never be rejected based on a single test. So as I say, the another part of the hypothesis is the alternate hypothesis. Symbolically, it is represented as an HA or H1. It is a logical opposition of null hypothesis. So if I say there is no change in the cells because of promotion campaign, so what is the opposite of it? That cells may increase because of the promotion campaign or cells may decrease because of the promotion campaign. In other words, when null hypothesis is found to be true, the alternate hypothesis must be false, or when the null hypothesis is found to be false, the alternate hypothesis must be true. So they are exactly opposite of each other. It can cover a whole range of values rather than a single point. The second stage is about setting up a suitable significance label. So the label of significance, it is denoted by alpha. The label of significance denotes the probability of rejecting the null hypothesis when it is true. That means somewhere we are talking about an error. Okay, even though my null hypothesis is true and even though we are rejecting it, that means there is some error. Maybe in our data collection method, maybe in our data analysis method, or somewhere there is an error, and because of that, even though null hypothesis is true, we are rejecting it. And so there is always a possibility of error. So the value of alpha varies from problem to problem, but usually it takes as either 5% or 1%. So we always take a chance that out of 100%, it might happen that 5% times we are wrong, or maybe 1% time we are wrong. So it is totally depend on that which problem you are trying to solve through your research. Usual level of significance is always a 5%. 5% level of significance means that there are 5 chance out of 100 that a null hypothesis will get rejected when it should be accepted. That means it's an error, right? So there are two types of error, type 1 and type 2 error. So because hypotheses are tested based on sample data, we must allow for the possibility of errors, right? There is nothing which is 100% true. There is always a chances of error. So a type 1 error is rejecting H0 when it is true. That even though it is true, we are rejecting it. That is a type 1 error. The probability of making a type 1 error when the null hypothesis is true as an equality is called the level of significance. That 5% means 95% we are confident that we will not make an error, but we are not sure about the remaining 5%. The type 2 error is opposite of that you accept the null hypothesis when it is false. Right? While type 1 is you reject the null hypothesis when it is true, while type 2 is you accept the H0 when it is false. So it is difficult to control for the probability of making a type 2 error. So statistician avoids the risk of making a type 2 error by writing the words like we do not reject the null hypothesis or accept, or will not never write we accept the H0, because based on only a single data we can never say that we are accepting the H0. We always write that we do not reject the H0. So let's understand it in some graphical mode. That, right, if your null hypothesis is true and you accept it, of course it's a correct decision. Then if your null hypothesis is false and you reject it, that is also a correct decision, which is represented in green color. Now if your null hypothesis is false, even you accept it, then it's a type 2 error. And when your null hypothesis is true but you're rejecting it, it's a type 1 error, right? That is what we have understood in the last two slides. So now try to understand it with the help of one example, right? So if say one person is there and he has been arrested in the that he has been arrested by a police. He has been charged. Okay, he has done a murder. कि उसने खून किया है इसलिए उसको पकड़ लिया गया है, right? So now there are four possibilities, right? That person is innocent, right? Maybe person has done something wrong, that he or she may did the murder. But so person may be innocent, or he may or may not done any kind of uh, wrong thing, right? So if person is innocent, उसने मर्डर नहीं किया है एंड नॉट फाउंड गिल्टी, कोर्ट में ये प्रूव हो गया कि दैट पर्सन हैज नॉट डिड एनी मर्डर, then it's a right decision, right? Because person has not did it. And if person is did the murder and court the lawyer has proved that the person is done something wrong and the person is involved in this murder, then the person may get some kind of punishment. So if he is guilty, he is justly convicted. So that is also a right decision, right? So we have a two right decision: innocent of crime, found not guilty, and guilty, justly convicted. Right? So they are the correct decision. So we don't need to worry about that particular quadrant. Now look at the remaining two, gray part. That person has done the murder but unjustly acquitted. That means that the lawyer has proved that person has did nothing wrong, and the court allow him the bail, or court will found that the person has not found guilty, right? But actually person has done the murder. That means it's a wrong decision. On the other hand, there is another wrong decision where the person is innocent, even though in the court it is proved that person has did the murder. That means person has been punished by the court. Maybe he has a lifelong imprisonment, or maybe he has been asked hanged till death, right? So which is the more we can say dangerous decision, right? कि गिल्टी है और उसको छोड़ दिया गया, या इनोसेंट है और उसको फांसी दे दी गई, which is the more dangerous decision, right? So innocent है and unjustly convicted, that is more dangerous compared to the guilty and not given any punishment, right? That's why we are more concerned about type 1 error rather than type 2 error. And that's why in research we are trying to control more the type 1 error, and we are least bother about type 2 error because it is not affecting our research much, right? And that's why here type 1 error we are, because innocent person has unjustly convicted, and they that's why we are more concerned about it. And so type 1 error, that we try to control by setting our level of significance at 5% level. Now the third stage is a determination, or sorry, fourth stage is a determination of test statistics. Right? Once your hypothesis is done, you decided the level of significance, right? Now your another stage is to decide that which test is to use to test your hypothesis. So that is depend on which kind of data you have, right? In the last slide we'll discuss about, okay, when to use which test. So to determine a suitable test statistic and its distribution, so there are various test statistic could be available, like t test, z test, f test, chi-square, and etc. Then it is required to determine the critical region. So what is the critical region? Before sample is drawn from the population, it is very important to specify the values of test statistics that will lead to rejections or acceptance of the null hypothesis, right? So we have to define a specific area, in which area if our calculation fall then it is accepted, and in which area if our calculation fall then it is rejected. So that particular area, definition of that area is known as a critical region. The one that leads to the rejection of null hypothesis is called the critical region. So here This blue part is defined as a critical region. Then we need to calculate our test statistics. So if we decided to go for t test, then we can go for calculation of it. If we decided to have a z test, then we'll go for the calculation of it. So that is the next stage. And at the last, after having all the calculations and everything, we'll make some decision about either rejection or acceptance of null hypothesis. So the hypothesis may be rejected or does not rejected depending upon whether the value of the test statistic falls in the rejection or acceptance region. So rule of rejection and acceptance, there are two rules. If your significance value, that is considered as an p value, is less than your level of significance, we reject the null hypothesis. And if our p value is greater than our level of significance, we do not reject the null hypothesis. Be mindful, we never write that we accept the null hypothesis. Because to avoid the type 2 error, we always write we do not reject the null hypothesis. Then another formula, or you can say another rule to make the decision about acceptance or rejections of null hypothesis is computed or calculated value if it is greater than your critical table values. So in every statistic books you find a table for t, z, f, and chi-square, right? So that is known as a table value. So if your calculated value is greater than your table value, you reject the null hypothesis. And if your calculated, or you can say computed value, is less than your critical or table value, you do not reject the null hypothesis. So there are two methods to rejecting and accepting the null hypothesis. And that is the last stage for the testing of your hypothesis. So at that stage, you define that either you are accepting the null hypothesis or you are rejecting the null hypothesis. So this is the table which I have talking about, right? So which kind of test we can use? How we can decide that either we have to go for F test, T test, Z test, or like chi-square. So it based on the nature of your data, you have to decide that which kind of test you want to use, right? So if your dependent variable is categorical or nominal, that means you have a categories like say male and female, or you have a categories like married and unmarried, right? So that is the category of your dependent variable. So if your dependent variable is categorical or nominal, and if your independent variable is also categorical or nominal, you can use this particular region: chi-square, logistic regressions, Kramer's V, or phi test. Now, if your dependent variable is still categorical and nominal, but your independent variable is collected on the interval or ratio scale, right? You have asked them to rate some factors. You have asked them the question on Likert scale. So they are become the interval and ratio scale. You can ask, you have asked about them about the income, price, everything. So they are ratio scales. So if your independent variable is a continuous and your dependent variable is categorical or nominal in nature, you can use the logistic regressions or point biserial correlations. Now, this third quadrant is talking about when your dependent variable is continuous. That means that your dependent variable data is collected on an interval or ratio scale, and your independent variable is categorical or nominal. Right? So, say customer satisfaction. It dependent on say age of a customer, right? So age is, you categorize the age, that age is from 20 to 25, 26 to 30, 31 to 35. That means it's a categorical variable which is independent variable. And your dependent variable customer satisfaction, so you have collected data on say 5 point Likert scale. the satisfaction, highly satisfied to highly dissatisfied. So if you have that kind of data, it will allow you to go for t-test, ANOVA, regression, point by serial, correlation. So these are the different options that is available. And now if you're both the variables, dependent and independent, both the variables are say interval on an interval or ratio scale, then you have two options, regressions and correlations. So this is how you can decide on that which kind of test you can use for analysis of your data and to test your hypothesis. So in our this sessions we'll focus on t-test, ANOVA, regression and correlation. So this is a typical, as I say, we learn the hypothesis testing, the basic statistical test using SPSS. SPSS is a social, or you can say statistical package for social science researchers. It is very easy to operate. If you are well versed with the Excel, it is easy to operate because it has a spreadsheet like the Excel only. So this is what the blank sheet, or you can say blank sheet of the SPSS, right? And if you look at the sheet properly, there is some tabs are given like file, edit, view, data, transform, analyze, direct marketing, graphs. Some symbols are representing here, right? So I'll just give you the demonstration of how to use these particular sheet, how to enter your data, and then we'll go for how to perform your t-test, how to perform the ANOVA, how to perform the correlation and regressions, and how to check the reliability of your data, right? So just let's start with that. uh, this is the blank sheet. Now if I want to enter my data into this blank sheet, there are two methods. Either I can copy paste my all the data from Excel to this file, or I can import them, right, from the folder where I have saved my data. So there are two methods of doing it. So first is simple copy paste, that like you can just copy this data from the Excel sheet and you can paste them in this particular sheet. Another way is that you can import them. So how you can import this data? So click on the file, click on the open, and open. There are four options. So we need a data, so we are going to import the data. So if you click on data, this kind of window will appear, right? So here you have to change that your data is in Excel form, right? So I can have my Excel sheet, right? Now where I have saved my data. So my data are on desktop in this particular folder. These are my final data, so I can open it. So that it will ask in which worksheet, because Excel has a different sheet 1, 2, 3, 4, right? So it will ask that in which worksheets your data are there. So I will, my data are in sheet 1. So if I'll write OK, so my data will appear here, right? These are my datas which is come here, which is imported here from my Excel sheet. Right, so these are the data that I have imported. Right, so this is my final sheet. Now if you look at here, we only see the numbers 1 2 2 1 4 2 1. So what that number is representing? So there are two views in SPSS: data view. So this is my data view, and another one is a variable view, right? So this is the variable view where you can define your variables. Like say for example, my first, whatever you write here in the first column, that appear here in the first that appear as a heading of the column, right? So if I write gender here, say I have written nothing, if there is nothing, so now look at here, so say I change the name as in say male. So now look at here, it is changed as a male. Now again, if I'll change something here as in gender, then it will change in your data view, right? So the first column of variable view will represent that the heading of your variable in data view, right? So numeric, right? Because we have given a coding, that's why our all values are in a numeric form. This is width of your cell, right? So it is, you can simply by dragging here and there, you can change the width of your column. Decimal, if you want a decimal, you can click here that I want the value up to 2 decimal. So now look at the value of in data view, there are 2 decimals are representing, and if I don't need any decimals, right? The next is a label. So what is the label? This label will appear in my output, that if I'll do say cross tabulation, if I'll calculate the frequency, then what should be the name of that variable? So that is a gender, right? So that appear whatever the name you want on your table or on the column of your table, that you have to write here gender. There is no word limit in the labels, you can write the entire questions also, but here in the name you cannot use any special character. Let's say for example, if I write vnn, then it will say variable name contain an illegal character, because it will not accept any like at the rate star, and it will not accept that kind of character, even it will not accept the space also, right? So here you don't have a much chance to give the full name space anything, but here, and it is only appear in this heading, otherwise it does not appear anywhere else. In even in your output also, all this whatever you have written in label, that will appears. Now what is the value? So when we have collected the data from our samples or from our respondents, we'll ask them what is your gender, male and female, what is your age, right? What is your experience, right? So they will give us number. Sorry, they will give us the answer not in numbers, in the text, right? But SPSS will not understand the language of text, so we have to convert them into the numbers. That's why we need to assign the values to it, right? So what is this value means? So let me tell you, right? So say I have a data on gender, male and female, so I have coded them. That is totally depend on researchers how they want to code it, right? If you wish, you can give the 2 number to a female and 3 number to a male. It is totally on researchers, because it is just a categorizations. Here that one will not carry any value, right? It is just a label that we are giving to the text, right? So if I say one and male, so when I go for the output, wherever in the gender column, wherever one is written, the SPSS will in output it will represent as a male. Two, so I have given female a 2, right? So that is how you can assign the values. Same way for the designations, that say I have a categories, HR professional and other employees. If you have a 3 categories, then you can have, like if you have a skilled, like here in age we have more than 2 categories, that those who are falling in 21 to 30, they have been assigned number 1. Those who are falling in the category of 31 to 40, they have been assigned number 2, right? Same way 41 to 50, number 3. 51 to 60 number 4. So same way you can go for assigning the values. This is my scale data, right? Always almost true to almost not true, 1 to 5. Then there is a missing value. So if there are any missing value in your data, it can represent it here. This is again a column width and height, and so you can change it. Alignment, that is either you want your data to be aligned right or center or left. So that is, see, if I did center, so here my data comes into the center. If I'll do it like right, so my data will goes towards right. So there is nothing much rocket science is there. Now here, these are the measures, right? So we know there are four types of data: nominal, ordinal, and scale data, interval and ratios. They are combinedly represented in SPSS as a scale. So if I say genders, male and female, that means it's my nominal data. If I say designations, HR and non-HR persons, that means they are my nominal data, categorical data. If I say age, again a nominal data, experience, again a nominal data, and my remaining variables are on a scale data because I have collected the data based on scale. And what is the role of your data? That is of course an input, because we are giving it as an input to find out some output. Right? So this is how you can enter your data, and you can label them and give the proper uh, proper look to your SPSS sheet. So now your sheet is ready to go for the further analysis. So now how will do a further analysis? So see here, there are, as I say, different tabs: edit, view, data, transform, analyze. And so we are much concerned about this two column, transform and analyze. And first let me introduce you with this tab, transform may sometimes we know that some of the items in our skills, some of the questions in our skills are reversely coded. That means if respondent has given response as a 5, then as a researcher we need to enter that data as a 1, right? So this is a reverse coding. So in transformed, you can reverse code by using recode into the same variable or recode into the different variable. Recode into the different variable. So say if my this particular question is a reversely coded, then I have entered it, right? So they will asking me, okay, what should be the name of my output variable? So say I will give the name, say v1, right? What is the label that I want to give? Say v1, sorry, 1, right? Now I have to define old and new values. So what is the old value? Old value is say 1. That means respondent has respond as a 1. But for me as a researcher, the new value is 5. Then I will add it. So if respondent respond as a 2, the new value for me is a 4, and then I can add it. Then if respondent has added 3, again as it is a 5-point Likert scale, it's remain as it is. Now if it is 4, it becomes 2, you have to add here. And now if it is 5, it become 1, right? And I have added all this 5, and then I can go for continue, and I can change. So okay, so where is my new variable v1? So now look at the variable view. In the last row you can look at this new variable v1, and we have to change it here. We on the, and in your data view also it is appear at the last column. See, look at here. There are 5 decimal. Sorry, there are 2 decimal point. Why it is so? Because in your variable view, it is 2 decimal. Now, if I keep it 0, now look at the data view, right? And it is reversely coded. So that is where you can use this transform function, where you can recode into the different variables. There are all other functions also, but right now we are not going to talk about it. Now let's talk about the basic statistical test that we can use for the hypothesis testing purpose. So analyze, if you look at this analyze, there are see various options are there. You have a descriptive statistic which has frequency, description, X flows, cross tabulations, ratios, your PP plots and QP plots. Then in the next is table, where you can form a custom tables and multiple response set. Compare means, where you can compare the two means. So you can perform one sample t-test, independent sample t-test, paired sample t-test and one-way ANOVA. Then there are linear models, generalized mixed models, correlations, right? Bivariate partial and distance correlations, regressions. So there are different types of regressions are there. Log linears, logit and probit model, you can learn through it. Uh, Natural networks, then classifications like cluster sampling, discriminant analysis that you can do with the help of classifications, dimension reductions, that is the factor analysis part that can be performed through this particular tab. Scales, so you can check the reliability of your data with the help of this reliability analysis. Some non-parametric tests that you can also perform. So when your data are on ordinal or nominal scale, say rank order data, there you cannot perform this t-test and ANOVA and all, right? So you have to go for non-parametric tests. So here all non-parametric tests are available. Chi-square, Mann-Whitney, Kruskal-Wallis, all these are the different non-parametric test. Forecasting that you can also do. Survival analysis can also be possible. Multiple responses, right? So sometimes you have been given a different factors and you have been asked, okay, whatever applicable to you can tick on it. That means we have a multiple responses, so you can define the variable sets through the multiple responses, and many other options are there. So now let's start with some basics like descriptive functions. And so you want to do or calculate the mean median mode of your data. Then click on analyze descriptive statistics and go to the descriptives. Right, so I want to calculate frequency can only be calculated for the nominal data, right? And you can uh, do the descriptive of any data like mean median mode. So say I want to calculate the frequency of my gender, just so you can click here on gender and you can import it into the variable sections. You can click here and you can import it. Here the options is given. Click on it. What do you want? Mean, standard deviation, minimum, maximum, range, variance, kurtosis, skewness. So we know that kurtosis and skewness are helpful in identifying the normality of data. So if you want to check the normality of your data, you can click on this two also, right? Then you want some, how you want a mean, ascending, descending. So whichever your preferences, you can click on that and you can continue. And now if I click on OK, then one output window will appear. See, this output window will talk about everything, whatever function you did, right? So say for example we did this coding part, then it is written here. Now we have calculated descriptive statistics, right? So gender and designations. So I have a descriptive statistics of this gender and designations. That in gender, the mean is 1.28 and designation mean is 1.63. Their standard deviations, their skewness and kurtosis. So if your kurtosis value, skewness value is between -2 to 2, your data is normal. Usually your data are normal. But from this, I don't know how many male, how many female, right? From this tables I don't know able to identify that how many males are there, how many females are there, how many HR persons are there, how many non-HR persons are there. So again I go to my data view. I can analyze descriptive and frequencies. So I do want to know how many male and female. So here, see here also you can have an option to calculate the descriptive. Like say designation wise and gender wise statistics. So say you need a mean. So you click on mean. If you need standard deviation, you can click on standard deviation. You need skewness, kurtosis. The same value is available from here also, and along with that, you can also get the frequency, that how many males, how many females. So if I click on continuous, if you want them in the chart form, say I want a bar chart also, then you can click on that. Format wise, you need it in ascending order, descending order, right? So you can change as per. Now, okay, that means I have calculated frequency. This is my first table. It shows the mean of gender, mean of designations, QNS kurtosis value, and also it gave me the data that out of total 54, the male is 39 and female is 15. So that is how you can uh, came to know that what is the ratio of gender in your data, and it is also represented in the form of graph also, right? This is the graph for gender, male, female. You can change the colors of graph and everything by double click on it. So that is a simple process, right? So that is how you can calculate the simple frequencies. Now let's go to understand the different test, t-test, gender test and everything. Now say for example, I want to know, my hypothesis is that, see this data is about, this data is based on this questionnaire, है ना? जो स्पेसिस की शीट हम अभी देख रहे हैं, it is based on this question, that is perception of the HRM practices among middle level IT professionals. Right, so it is a study of ITES firms, Ahmedabad based. Now, if I want to know, okay, is there any difference in the perception of, say, HR professional and non-HR professional? If there is, so my hypothesis is there is a significant difference in the perception for the HRM practices of HR professional and non-HR professionals. Or my another hypothesis, maybe there is a significant difference age wise, there is a significant difference in the perception of my respondent for the HRM practices. Or I can say there is a significant difference gender wise, there is a significant difference in my um, respondents. So they could be my hypothesis, they are my hypothesis, researchers hypothesis. That means they are alternate hypothesis, and I always want to reject my null hypothesis. So what are my null hypothesis? That there is no difference, there is no difference. Now if you look at this questionnaire, there are 20 different statements are there. right, which are representing the different HRM practices, administrative practices, change practices, or say employee engagement practices and all, right? So there are 20 statement, and 4 practices has been taken, and strategic practices, which is represented by 20 different statements. So I want to know the differences. So what can I do? So say for example my first 5 statement, that means this variable 1, 2, 3, 4 and 5. This are representing the administrative practices, right? And I want to check the difference in the perception about administrative practices as a whole, not as a single state, right? So what I can do, I first need to find out the whole, or I can say I need to find out the sum of it, or you can say mean of it. So this 5 statement will represent my administrative practices. So what I can do, I can go to data, and then I can calculate the mean of it, or you can say the property of it, or I can go to the transform also. Transform, I can go to the compute variable. So what is my target variable? Say admin practices, that is my new variable. Administrative practices, that is my new variable. Now this first statements, so first I need to, here I need to go to the statistical test, because we are more concerned about, and I can click on mean. Here if you click on statistic, in the below box it represented that which are the statistical methods that is available. So I want to calculate mean. When I click on mean, and with this arrow I can keep it here. Now there are 2 question marks. So now I can import my data here. Question 1, then there is a comma, then question 2, there is a comma, question 3, there is a comma, question 4, question 3 and 4, we need a comma, and last is question 5, right? So this 5 question is talking about administrative practices in any organization. Now if I keep it here, and now if I click on OK, okay, so here it is written variable name contains an illegal character. Why it is saying that? Because I have given a space here, so it will not accepting any space. Now where is my data? So again I have to go to the data variable view. Look at, the last variable is added as an administrative practices. I can give here the name, right? I can write here this almost, you can copy paste it also, right? So if I say copy, and I can paste it here, so it can also be possible, right? My data is on scale, and it is represented into the last column, right? Now I want to check the differences, so I can go to check the differences. So go to analyze, compare mean. Now we want to check the differences in gender for their perceptions. We want to check the differences in designations. So in gender there are 2 categories, male and female. In designations there are 2 categories, HR professional and non HR professionals. But in age there are more than two categories, right? So when we have only two categories कि जिसके बीच का हमें difference ढूंढना है, we can go for independent sample t-test. So I click on independent sample t-test. This window will appear. So which is my test variable? मुझे किसका difference identify करना है? So I want to identify the difference in administrative practices of whom? Of say gender. So they are my grouping variables. So now if you enter it in grouping variables, this question marks will appear where you need to define your groups. That means whatever the value you have given at the variable view, that you have to write here, that my male is a 1 and female is a 2. If you have given it as a 2 and 3, then you have to write here 2 and 3. If you have given it as a 0 and 1, then you have to write it as a 0 and 1. Okay, continue. Options. So now look at here. Confidence interval percentage 95 percentage. That means your level of significance is 5 percentage, 0.05. Right, so it is here. You can change it also here by simply clicking say 99. That means your level of significance is 1 percentage. If I'll write here 90, that means your level of significance is 10 percentage. So here by default it is always a 95%. And now if I click on OK, so say this is my t-test table, right? So here you have a frequency, male 39, female 50. Now this is your t-test table. It is a very long table. Now how to read this particular table? So first you have to look at here, Levin's test for equality of variance. This is an assumptions of t-test, right? If you remember, when we calculate the t-test, we always have an assumptions. There variance of two populations. That means variance of male and variance of female are equal. That means your sigma 1 is equal to your sigma 2, right? So if that means we want that sigma 1 is equal to sigma 2, and then we can perform the t-test. So to know that either that assumption is true or not, we first have to look at this value, this f value and significance, Levin's test value. So here the significance is 0.886. That means this is your significance is your p value. That means your p value is greater than of your level of significance, that is 0.05. So when your p value is greater than your significance value or level of significance, that means we do not reject the null hypothesis, right? And when we do not reject the null hypothesis, what is our assumptions? That sigma 1 is equal to sigma 2. There is no difference. That is our null hypothesis, right? So if your this value is greater than 0.05 percentage, you have to look at the first row to check the t value. And if your this value is less than 0.05, that means it violating the assumptions of the t-test. It is violating the assumptions of t-test, and you can look at the second column, right? So here again our significance value is 0.896, which is greater than 0.05. That means our p value is greater than our alpha value. Then remember the making the decision part or stage. When our p value is greater than alpha, we do not reject the null hypothesis. That means if my hypothesis is there is a significant difference in the perception of gender for HRM practices of their company, right? If this is my alternate hypothesis, here I am not rejecting the null hypothesis. That means there is no significant difference. I am not rejecting the null hypothesis. I'm not saying I'm accepting the null hypothesis. I am not rejecting the null hypothesis. That means there is no significant difference in the perception of gender for the different administrative practices. Right? That is how you can perform the t-test. So when you have two categories, you can go for t-test. When you have more than two categories, say age, right? So in our data, age, say here, if you look at the variable view, and if we go here, then age wise, there are more than two categories. There are four categories. So we cannot perform this t-test. We have to find out the difference, we have to go to the compare mean, and we can go for one-way ANOVA. So in ANOVA, we are again checking the difference for our administrative practices, and your factor is, that means for which category you are checking the difference, for age. Now here again there are different tabs. So you can click on contrast, polynomial, or if you want anything, you can click on it. This is important, post hoc. So here we are generally click on this Tunkeys 1 and B test. And then here look at this significance level 0.05. Continue. Options are given. So do you need descriptive? Yes. You are need to click on homogeneity of variance and continue. And go for OK. Now see, one-way ANOVA. After descriptive, there is table test of homogeneity of variance. It is again a Levin's test. So T test में जो assumptions है, ANOVA में भी वही assumptions है कि every population has an equal variance. That means your sigma 1 is equal to sigma 2 is equal to sigma 3. That means our this value must be less than 0. If this value is less than 0.05, we cannot perform the ANOVA. So we always want that this value, significance value, should be greater than 0.05. So our test of homogeneity of variance will not violate the assumptions of ANOVA. So now we can look at this table. Again, look at this value 0.103, which is again greater than 0.05. That means there is no difference. Age wise also there is no difference in the perceptions. Now what is the importance of this table post hoc? This table is only useful if here there is a difference. If your this significance value is 0.0 less than 0.05, then and then this all tables are of useful, right? Because in ANOVA we have more than two groups. So this difference is between which group? Either the difference is between 21 to 30 age group, or 21 to 30 and 31 to 40 age group, or it is between 21 to 30 and 41 to 50 age group. If you want to know that, then these tables are of use. So if your this value is less than 0.05, you can look at the post hoc test and identify that exactly difference is where and in which group. So that is how you can perform the basic statistical test like mean, t-test and ANOVA. One more thing I would like to introduce to you is the checking the reliability of your data, Cronbach alpha. So you can check the reliability of your data by going to analyze, skill and reliability analysis, and you have to choose only those questions where you have collected the data on skill, right? You can choose all that data, right? And you can click on OK. So see here, your reliability statistic is here. alpha, which is more than 0.60, that means your datas are reliable. So your datas are reliable. So that is how you can perform the basic t-test and ANOVA using the SPSS, and how you can import your data into the SPSS. So that is all about from my side. If you have any queries, you can always post it to me, and at my best I can resolve all your queries. Thank you for your time, thank you for listening to me, and I hope this lecture will very much useful to you, and you have enjoyed this particular lecture.